Good morning, my YouTube viewers. It's Crystal. In this video, what we're going to do is we're going to create a summary table using our inbuilt dataset, mtcars. Because mtcars is, from what I understand, is one of the best datasets to actually in R to create a summary table. So the first thing that we do is we call up the dataset. So data brackets mtcars, and then we're going to convert the data set to a data frame. So df becomes data.frame brackets mtcars, and then we're going to call up the structure of the data frame as str brackets df. So you can see it's a data frame with 32 observations of 11 variables. So your variables are a column of data. So you've got mpg, that's miles per gallon, cylinder, cyl, disp, hp, that's horsepower, drat, I don't know what that is, wt, I'm assuming that's weight, qsec, don't know what that is, vs, don't know what that is, am, I don't know what that is, gear, I think that's the number of gears, and carb, so I'm not sure exactly what that is. I don't know a lot about cars because I don't even own a car. But this is what you get for your mtcars. And then, so we do a summary. We just do a summary of it. So you do summary df. And then when you do summary df, you get your minimum, your first quartile, your median, your mean, your third quartile, and your maximum. So your minimum is the lowest value. The first quartile is at the 25th percentile. Then you get your median. The median is actually the center of the vector. And so since there are, let's see what we've got. "32 observations." So that means that the data frame is even numbered. And since that data frame is even numbered, what you do is you take the two middle numbers, you add them together, and you divide them by 2, and that's how you come up with the median. Now your mean is the average, and average is you sum all of the elements in the vector, and then you divide it by the number of elements in the vector. So you can see your median for MPG is 19.2, but your mean is 20.09. So you can see that there is a difference between the median and mean. Then you've got your third quartile, which is the 75% range, and then you've got your max. That's your maximum. And so they give you all that information for all of the numeric columns in the data frame. And so all the columns in the data frame are numeric, so that's all you get. So now we're going to look at the key statistics for each variable, and we're going to use a homemade function that we've made ourselves. So sapply brackets df, that's your data frame, comma function x. So that's the function that you are creating, and it accepts x as an input. So you've got c brackets mean equals mean x, sd equals sdx, min equals min x, q1 equals quantiles x, comma 0.25, median equals median x, q3 equals quantile brackets x, comma 0.75, and max equals max x. So you get a lot of the same values in this homemade function that you get in the previous inbuilt function, which is a summary. The only value that's in this homemade function that's not in the summary is SD, and that's your standard deviation. So we run it. We've got this function, so we run it. So key statistics. So we use df for that, and we use function x, and you can see that we get a matrix of 7 times 11. So you've got the 7 statistical functions being mean, standard deviation, minimum, Q1, median, Q3, and max, and then you calculate those values for every numeric column, and all of the columns in this particular data set are numeric. So that's good. So now what we're going to do is you're going to calculate the correlation. So you're going to create a correlation matrix, and that just tells you the relationship that each column of data has with the other. And so that's why you're going to see like MPG has a 100% relationship to itself. And then you go through all of the other columns of data next to the MPG, and you can see that they all have a different number. And the different number reveals the positive or the negative relationship that they have to each other. So a positive number is a positive relationship. A negative number is a negative relationship. And 0 is no relationship at all. And then what you can do is R also has a 5-number summary. So if you want the 5-number summary, you can calculate the 5-number summary using sapply brackets df, comma, 5num, and so that gives you your 5-number summary as well. And I don't really use the 5-number summary, but it is a statistical value that people can use if they want to. Okay, and then now what we're going to do is we're going to do the mean MPG by cylinder count. So you're going to say aggregate brackets MPG, and I think this squiggly sign is a tilde, CYL cylinder, comma, data equals DF, comma, fun equals mean. So function is your mean. So what you're going to do is you're going to create a data frame that gives you the mean miles per gallon for the cylinders, being either 4, 6, or 8. Then you have your multiple summaries by group. So you have your aggregate brackets C-bind. So C-bind is when you combine the columns of either vectors or columns of a data frame together. So this is going to be brackets MPG, comma, HB, comma, WT brackets. And I think that's a tilde, cylinder, comma, data equals mtcars, and function equals mean. But we're using, it should be DF, because we made it DF. It says data equals mtcars. It says data equals mtcars, but we have already converted mtcars to a data frame. So it should be DF. So I'll just try it, hope it works. And the reason why I'm hoping it works because I had my laptop down. So what we're going to do here, so that's what I have to do because I just came back to my laptop after not doing anything with it last night. So here we go. So DF is the correct data frame to use because I converted mtcars dataset to a data frame and I called it DF. And so here you have the number of cylinders, 4, 6, or 8, and the miles per gallon, HP, that's horsepower, and WT, I think that's weight, and you have the mean values of all of that. So now we're going to use tapply for a single variable summaries, tapply brackets, and then here we go. That should be df. So now you've got your single variable summaries, and so that gives you the value across that. And then we also have cross tabulation, cylinder times gear, but also it should be df, not dfcars, because I had converted mtcars to a df. I had renamed it df. So here's your cross tabulation. So you get your table, 468 for your cylinder, and then you get your gear as well. So we're going to calculate the proportions. So now the proportions are your table for your cylinder and your gear, and it gives you proportions for your cylinder 468 and your gear of 3.5. And then now what we've done is we have a compact publication style summary table. Theirs becomes names brackets df. And so summary table becomes data.frame, variable equals fares, mean equals, and all of these should be dfs. S apply brackets df mean, st equals s apply brackets df sd, and min equals s apply brackets df min. Median is s apply brackets df median. And max is s apply brackets df max. So I'll run it again. So we created a table that has all of your statistical values that you would like to have in a column of data, and all of the variables or columns of data in the mtcars data frame as a row. And so that gives you the mean, standard deviation, minimum, maximum, and median. And so basically that's how you create a summary table in mtcars, which we converted to a data frame. And you can use this coding with any other data frame that you would like, but I just chose mtcars because mtcars is like one of the best data frames in R to create a summary table. So that concludes our section on miscellaneous subjects in data manipulation in R. And then so my next video will be another topic in statistics with R. So I hope that you decide to watch it.